Hello and welcome back to One Day to Get 5 May for AP Precalculus. This is episode 53, and today I have a problem for you from Unit 3. Alright, so today's problem is an FRQ question. It's one part of an FRQ. It's from Barron's AP Precalculus Review Guidebook. Okay, so, as shown in the following diagram, a ball is attached to the end of a spring that is suspended from a ceiling. So, point C in the center of the ball is 1.8 meters from the ground. When the ball is released, it rises to point P, which is 0.4 meters from point C. It takes the ball three half seconds to go from its resting position at point C to point P and back to point C. So it's not that it takes this three half seconds or just 1.5 seconds. It's that it takes this and this, right? Okay. After the ball is released from rest, the height of point P above the ground periodically, so it repeats, periodically increases and decreases. The sinusoidal function h of t models the height of point C above the ground in meters as a function of time, t in seconds. Okay, so the question is asking, after all this description, is the graph of h and its dashed. 1 second. Okay, actually, I have the book. I forgot to include the diagram when I included the picture. So, let me draw a quick sketch. So, it looks like. Okay, so this is the dashed midline. Okay, so this is E. This is G. This is H. This is J. This is K. So E, G, H, J, K. So this is what it looks like, somewhat. Okay. And then it continues to repeat. So yeah, anyways. Alright, so it's saying the graph of H, this is H, and its dashed midline for 2 full cycles is shown. 5 points E, G, H, K, and H, J, and K are labeled in the graph. No scale is indicated and no axes are presented. Determine possible coordinates T, H, and T for the 5 points that are listed here. Okay, so give the problem a try. Hopefully you already did. But if you haven't, give the problem a try. And then check back and see how you did. Alright, so what we're given is that, initially, the ball is, it's 1.8 meters from the ground. So this is 1.8 meters. And then when it gets released, it rises up to point P, which is 0.4 meters higher, which is going to be 2.2 meters. Now the midpoint is going to be between those. That's going to be 2 meters. So we know that it goes from point C, which is at its lowest, to point P, which is its highest, so that's H, to K, all the way to K. We know that it does that in 3.5 seconds. We know this does it in 1.5 seconds. Alright, so we know that we're assuming it's going to start at t equals 0 seconds. We're assuming it's going to start from t equals 0 at its lowest point and then rise to its highest point at point H. So for point E, we can have 0, 1.8. Okay. Now for G, it's midline. We know that it, it should, this should be, this is going to be half the distance from the lowest to the highest. And this is going to be a quarter of the total distance. So this should be, let's see, 1.5 over 4. 0.375, I think. I'm just going to double check. Actually, no. What I'm going to do is I'm going to write this as a fraction, so it's 3/2 seconds. So G is going to be 3/2, so we're dividing it by 4, so it'd be 3/8 second, and then it's going to be at the midline, so 2. H is going to be at the highest, so it's going to be 2.2, and the time is going to be half of 3/2 seconds, so 3/4 second. Now, J is going to be in the midline again, so it's going to be 2. But this is going to be, see, this is another fourth of the time, right? So we want, we want 3/4 plus 3/8, which is 6/8 plus 3/8, which is 9/8. So 9/8 second. And then K is finally, we know it's going to be at the lowest, so it's going to be 1.8, and then it's going to be at 3/2 seconds. That's the full period. Okay, so yeah, I'm not sure I did a great job explaining it, but oh yeah, the one thing I do want to go over is the reason why I'm saying that it's going to the reason, like, how I figured out that this is going to be a fourth, this is going to be a fourth, this is going to be a fourth, this is going to be a fourth. The way that I figured that out is just based on sinusoidal functions. Like, for example, if you have, like, sine, or we're not given necessarily that's a sinusoidal function, but later in the question it says it is. So if we just assume it is right now, if you have something like, I had a better graph. How about I do sine? If you have something like sine of x, so it's going to go like this. So it's going to reach its highest at pi over 2. And then it's going to reach its lowest. Well, it's going to be 0 at pi. Then this is 3 pi over 2. This is 2 pi. It's, if you notice, its midline, which is at 0, is always going to be, like, the the crests and the troughs and the midline points are all going to be equally separated by pi over 4, right? Or no, sorry, pi over 2. Because this is pi over 2. 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 Right? And that's kind of logic I was using there, that these are all going to be equally separated. But anyways, that might not always be the case for every periodic function, but later in the question you see that as a sinusoidal function, which we know that applies there, so that's kind of where I got that from. But yeah, I didn't really show that here. Anyways, I hope that you found this helpful. And I hope that you have a good rest of your day.